So what we actually do is we follow one of the ISO standards through, which has a lovely little process to take you through what's called a failure modes, effects and criticality analysis, known as FMECA for short. It basically tells you how to do a cost-benefit analysis across your whole plant to decide which bits need which sort of maintenance. It's a standard that's come from the condition monitoring area, but it doesn't just say you've always got to do condition monitoring. It's much more generic than that. It starts off with an equipment audit. So your first stage is to decide what it is in your process which could give you a problem. So you list out all the various parts that you have and decide how critical they are to your system. Then moving on from there, you decide the reliability and the criticality of those parts. Now, reliability and criticality are slightly different aspects, because reliability is how long a machine or a process is going to keep working without any failure, whereas criticality is how important it is when it fails. So you can have some highly reliable equipment that is non-critical, and you can have some critical equipment where you really need the reliability that has some very high wear factors to it as well, so that you have to keep a close eye on it. So you basically go through your inventory list and work out the failure modes that can affect all of those parts, and then look at the criticality of those failure modes and what it's going to do to your whole process. And for each failure mode that you identify, you then do what's called a failure mode symptoms analysis to work out how you could spot the early signs of that failure. These have got to be measurable factors. So a symptom which involves something blowing up and not being usable anymore has told you there's a failure, but it's no use as an early indicator. Whereas something like a temperature which goes up over the last 3 days before a failure occurs will give you enough time to react. And in the vibration analysis side of things, quite often you may get 3 months before any failure, you'll get a small fault indication that shows you something's starting to happen. And those are the things that are perfect for applying condition monitoring to. You also need to consider a whole risk profile. So if you've got a critical machine that is very likely to fail, it's a much more risky machine than a very reliable one. Or if you have a machine that doesn't affect the rest of the process when it fails, then you will get a much more it's much less risky to run that on a run to failure scheme, for example. And a good example here might be the radio in your car. If the radio breaks, it's not going to stop you going from A to B. You'll still be able to get in the car and drive somewhere. It's not affecting your process. The only side effect is you might miss some travel news and get caught in a traffic jam. But it's not a critical part of the process. The car will still work without the radio. So these are the sorts of things that you can consider when you're building a maintenance strategy. So having gone on from our reliability and criticality audit, we've now got to select the right maintenance strategy. And here we're thinking about cost against criticality. So basically, the higher the cost of the repair, then the more carefully you have to think about how you're going to do that maintenance. And the more critical the item, then the less risk you can attach to it. So preventive maintenance, where you're doing things in advance, can be very useful for critical items with a high cost of repair. In those cases, you will probably apply some condition monitoring as well, because it's so important that the machine keeps running. You want to know what's going on with it, even though you're still going to maintain it on time. Then you have a large section in the middle where condition-based maintenance makes a lot of sense, because it cuts your costs and it reduces your risks at the same time. And then down towards the bottom left-hand corner, you've got the low cost of repair and low criticality, where you can actually say, okay, I'll just fix that if it breaks. It's not going to affect my process.